Hey everyone, let's start with question number 17, Digital Electronics, asked in GATE examination 2025, branch Computer Science and Engineering, set 1, forenoon. Consider the given sequential circuit designed using D flip-flops. The circuit is initialized with some initial values, initial states. The number of distinct states of the circuit will go through before returning back to the initial state is. So everyone knows the basic, it is as nothing but twisted ring counter, or also known as Johnson counter. So even if you don't know what are the number of states depending upon the number of flip-flops, I will write here is 2n, but I will verify this. So if n is 4, 4 is number of flip-flops, n is number of flip-flops, so your total states is 8. And I will let you know one interesting point in this question. In answer key, official answer key, it is given 7 to 8. It means 7 and 8. Both answer were accepted. We got that 8 is correct, but how come 7 is correct? I will let you know. So let's start writing Q0, Q1, Q2, Q3. Let's assume the initial states are 0, 0, 0. You can assume any state, whatever you want. You will get the same answer. So this is the Q3 complement goes to Q0. Q3 complement goes to Q0 every time. So what happens in first clock? 0 becomes 1 and the entire bits get shifted. Comes 0, here comes 0, and here comes 0. The same would happen again. This bit becomes 1. Now this bits got shifted, and this goes on and on. 1, 1, 1, 0, and again all becomes 1, 1, 1. Again we didn't get the same state from which we have started. Again it becomes 1 complement becomes 0 here, and here comes 1, 1, 1, again 0, 0, 1, 1, 0, 0, 0, 1, and now all becomes 0, 0, 0. So you got the initial state. Now we will write the number of states. 0, here comes 0 state. This is an 8. 0 goes to 8. Now it goes to 12. Then it goes to 14, which further goes to 15. Now this goes to 7. Now 3, 1, and finally it returns to 0. So you can see that there are total 8 states. Now the interesting point is how comes the answer would accept 7 also. See, in question it is said the number of distinct states the circuit will go through before returning back to the initial state. So it's saying that before returning to the initial state, how many are distinct state after the 0. So you don't have to count 0. You have to see what are the distinct state before returning to 0. That is 0 is our initial state, which I have assumed. So it is written that before returning to initial state, how many distinct states were in the counter? So there are 1, 2, 3, 4, 5, 6, 7. That's why answer 7 is also accepted based on the question asked, the number of distinct states the circuit will go through returning back to the initial state. This is only the one of the tricky statements asked, but most of the students were, because it is nothing but generalized twisted ring counter or Johnson counter, so you can go through this, or it is recommended to always have a good reading of question. Thank you.